All right, so there's 4 types of factoring that we'll do, and there's actually one that kind of comes into play when we do these two. That's called perfect square quadratics, and that one there's a shortcut to or another way to do it, but these work every time, so we're just going to stick with these. And if you remember how to do perfect square quadratics, that's great. If you don't, then that's fine too, because these will work every time. All right, so first of all, if you see a binomial, right? If we start out with a binomial, so there's 2 ways we can end up with a binomial. One is if c is equal to 0, right? And then you only see ax squared and bx. If that's the case, you're going to do the greatest common factor method, right? Where you factor out the GCF, the greatest common factor, and then you're going to be left with terms on the inside, okay? And you end up with just a binomial, right? So one number on the outside and a binomial on the inside. All right, and so that's GCF factoring, and we'll talk about how to do that, or kind of refresh on how to do that. The next one is, what if b is equal to 0? If b is equal to 0, then you don't, like here we have x's in common, right? So you're going to have a GCF. So I should put an x out here actually with the a. So ax, and then you'll have something inside, okay? All right, so if b is equal to 0, then you're going to do difference of 2 squares, or at least that's the possibility. It doesn't always work out that way. You do have to have a negative here, or you do have to have, the signs have to be different in order to use a difference of 2 squares, right? And hence the word difference. So if for a difference of 2 squares, what you're going to do is you're going to take the square root of a, and you're going to put it here and here, and then you're going to take the square root of c and put it here and here, and then you're going to have a plus and a minus, okay? So that's how difference of squares works. And you've probably seen that before. All right, then we have a simple quadratic, which is more like what we just saw. And that's where we're going to end up with something like this, where we have a product of 2 binomials. Now, we also have a product of 2 binomials with difference of squares, but with simple quadratics, it looks more like what we just did, where we have our product and we have our sum, right? Our product term and our sum term, and those are our clues to figure out how to get to these values p and q, which represent our roots, okay? All right, and then the other one we have is a complex quadratic, and that's where you have a value bigger than 1 for a. So let me go back here for a second. So a simple quadratic is where a equals 1, so you have an invisible 1 here. A complex quadratic is where a is greater than 1. And that one looks similar, but you'll have coefficients in front of x instead of just 1s in front of x here, invisible 1s. So in complex quadratics are a little different. We have to use, our method is going to change a little bit, and it's going to just be a little more work, a few more steps. But I have a way that hopefully will make it pretty straightforward for you, that I learned from another teacher back in the day. So this is a great chart to have, just to recognize, okay, if I see something that looks like this, then I know this is the type of factoring I'm going to use, right? And so, and this is pretty comprehensive as far as like what we could possibly see, right? And it covers just all the types of quadratics that we may come across that we can actually factor.